Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So within this module, we are currently on the second topic, that is introduction to operating systems. So in this topic, through a series of videos, we understood what is an operating system and what are its fundamental duties. So as we already know, the operating system is a special piece of software that manages the computer hardware. And in the previous few videos, we have been looking at how the operating system manages the individual hardware components like the CPU. Then we looked at memory, IO devices, and then we looked specifically at the storage. So we studied that the operating system has two fundamental duties with respect to any piece of computer hardware. That is to make sure that it is easy to use, and second, it has to ensure that the hardware is used efficiently. Now, the point is, apart from these fundamental duties, there are several other miscellaneous activities as well that the operating system does in the computer system, which are very important for the functioning of the computer. And in this video, we are going to see what else does the OS do apart from managing the computer hardware. So let's get started. So in the previous few videos, we have studied what is an operating system and what are its fundamental duties. So just to quickly recall, the operating system is a special piece of software that is responsible for managing the computer hardware. And when it comes to managing the hardware, there are two fundamental responsibilities or roles you can say that the operating system has to fulfill. The first one is to make sure that the hardware is easy to use. And to make any piece of hardware easy to use, the operating system provides abstractions. So let us recall the abstractions that we have studied in the previous videos. So in the case of the CPU, the operating system provides the abstraction of a process, that is a running program. Then in the case of memory, the operating system provides the abstraction of an address space, which is basically a collection of addresses which the operating system provides to every process, so that each process is given the illusion that the memory is private to it and it is very large. Then in the case of IO devices, we saw the concept of device drivers. So device drivers are not technically an abstraction. They are not a virtual resource, I would say, but nonetheless, device drivers abstract out the complexity of the underlying device controller interface, which makes the IO devices easy to use. And then we saw the storage devices, right? So for storage, the operating system provides the abstraction of files and directories, right, where we store our data persistently in an easy way. So these are the different abstractions that the operating system provides in the context of these hardware resources, and that is what makes the hardware resources in the computer easy to use. So the next fundamental responsibility of the operating system is to make sure that the hardware resources are used in an efficient manner, and for that it does a careful resource management. So basically there are several user applications in the computer system, and all of them require the hardware resources for doing the processing, and these hardware resources are shared and limited in nature, right? So the operating system has to keep track of all these hardware resources. It must be aware how much is available, how much is in use, and when the user applications make request for these hardware resources, then it must be able to allocate these resources properly. And finally, when it comes to resource management, it's not just resource allocation. There are several other activities that the operating system has to do when it comes to managing a resource. And in the previous few videos, we have already looked at those examples. So basically, these are the two fundamental responsibilities that the operating system has with respect to the computer hardware. So apart from fulfilling these two fundamental responsibilities in the computer system, the OS does a whole bunch of other things to make sure that the computer runs in a smooth and proper way. So now what we'll do, we'll take a few examples and understand what are all the other activities that the operating system does in the computer system. So the first activity that we are going to talk about is the boot up and shutdown, and this is performed by the operating system. So before we can start using the system, the first thing we do is that we boot it up. What happens during the boot process and why is it required? basically when you press the power button, at that time the system is in a kind of uninitialized state. It's not ready for use. The memory is empty, the different hardware resources, the IO devices are not initialized. So what is the first thing that happens? The operating system is first of all loaded from the disk into the memory, and once it starts executing, it then initializes the different hardware resources. It loads the device driver, and in this way it initializes all the hardware components, right? It brings the system to a state where we can start using it. And another thing is that as part of the boot process, it also performs the user authentication, where it verifies that the user who is going to use the system is actually authorized to do it or not, right? And once the user logs into the system, that is when they can start interacting with the system, they can launch their user applications. But before that, this boot process is absolutely necessary, without which we cannot even start using it. So this is something that the operating system does for us, and you can imagine that without this boot process that the operating system does, we cannot even start using the system, right? So once the system is booted up, then we can start using it. And once our work is completed, then what we do, we shut down the system. And this shutdown process is also taken care of by the operating system. So there are several important things that the operating system must do during the shutdown process. For example, if there are any running processes still there in the system, then the operating system has to properly terminate them. Then let's say we made any modifications to a file and those changes have not been committed to the disk. Then in that case, the operating system has to ensure that those uncommitted changes are pushed to the disk, because the disk is the only reliable storage in the computer system. And while shutting down the system, we have to ensure that all of those modifications are properly pushed to the disk, and this is taken care of by the operating system. Then about the IO devices, just like during the boot up process, the operating system initialize them. During the shutdown, it has to properly close them, right? And these are all the different termination activities that the operating system performs during the shutdown process. So this is how the boot up process and the shutdown works. And these are two very essential activities that the operating system does for us in the computer. The next point is that the operating system provides the user with a user interface. So here is an example of a user interface from the Windows operating system. So as you can see, first of all, there are several icons on the user interface. And if you double click these icons, then it allows you to launch the other user applications, right? Then apart from allowing you to launch applications, it also gives you a view of the different files and directories that are present on the computer system. Then there is this taskbar. As you can see, there are several useful features on this taskbar. For example, you can search your applications and files. There is a search bar. Then it displays the date and time, the battery level, the network connectivity, whether the sound is muted or not. So all of these useful pieces of information are present on the user interface. So this user interface, in a summary, basically allows you to launch different applications and gives you a view of the computer system. It allows you to interact with the computer system, right? And this is provided by the operating system. Well, technically speaking, this user interface application is not exactly in the operating system kernel. It's a layer of software that runs outside the operating system, but nonetheless, it is heavily based on the interface that is exposed by the OS. It's a piece of software that is based heavily on the operating system, right? So this is how the user interface, which is a very crucial part of the computer system, is provided by the OS. And if you see, the operating system vendors, the manufacturers, often ship the user interface with the OS itself, right? When you install the Microsoft operating system, the Windows operating system, then this user interface comes with it, because without this user interface, you would not be able to use the system. So this is how the operating system provides the user interface. The next point is that the operating system provides a protection mechanism for all of the hardware resources that are there in the system. So basically, if you see, there are several resources in the system. There is a CPU, memory, IO devices, storage devices, and all of these are shared by the different user applications. So when multiple entities are sharing a particular resource, then in that case, there have to be certain safeguard mechanisms, certain protection mechanisms, in order to ensure that that particular resource is not misused by any particular entity, in this case the user applications, because they have to be allocated to all the application. If one particular application misuses that resource, then the sharing of resource would not be possible. So there are certain protection mechanisms that the operating system provides in case of all of these hardware resources, so that they are shared in a proper way. So let us look at what are the different kinds of protection mechanisms that the operating system provides. So let's talk about the CPU. So in the case of the CPU time is shared by all the user applications. Basically, the processes have to execute their instructions on the CPU, and what they require is the CPU time. But if any particular process takes control of the CPU and then does not give it up, then other user applications would not be able to run, right? So there should be a limit on the time that any particular process can use the CPU. They have to give up the control of the CPU after some point. So in this case, in order to ensure that any particular process does not indefinitely take control of the CPU, what the operating system does, it takes helps of timers. So there are certain hardware timers in the system, and whenever the operating system gives the control of the CPU to any particular process, it starts the timer. If and once the timer expires after a certain time, if the process has not given up the control of the CPU, then what the operating system does, it forcefully takes control of the CPU from that process. So this mechanism ensures that no particular process can hog over the CPU, that is run on it for an indefinite amount of time. So this is how the operating system protects the CPU from misuse. Next, let us talk about the memory. So memory is where all the processes live. So the data that belongs to the different processes is in the memory. If we do not have any protection mechanism for the memory, then one process could access the data of another process, and this is something we do not want. So what the operating system does, it provides the concept of an address space. We have already studied what is an address space in the previous video. So basically, what the operating system does is that it forbids the individual processes from directly accessing the physical addresses. So now they cannot access the data of whichever data that they want. They are provided with a virtual address space of their own, and all memory accesses will happen through that virtual address space. And the way the virtual address space has been implemented, as we know, any process can access their own, only their own data. They cannot access the data that belongs to other processes. So this is how, by providing this abstraction of an address space, it works as a protection mechanism so that any given process cannot access the data that belongs to other processes. So this is the protection mechanism that is there for the memory. So when it comes to the IO devices, the protection mechanism is even stricter. So these are devices which are very crucial for user interaction because they are used for input and output, and they define how the user uses the system. So in case of the IO devices, the operating system does not trust the processes, the user applications to use them properly. It completely forbids the user applications to directly perform the IO operations. Whenever they have to perform any input or output, they request the operating system, and it is the operating system that performs the IO operations for them. The device controller interface, the registers in those interface, everything is completely forbidden for the user applications. So you see, in case of the IO devices, there is a very strict protection mechanism from the operating system. So now let us talk about the storage devices. So these storage devices are used to store our data persistently in the form of files and directories. Now there could be several users in the computer system, and each of them would be having their files and directories on the storage device. If we do not have protection mechanisms over the data that is present on the storage, then there could be several problems. For example, let's say there is a user A and they have a file, and let's say there is another user B, and without the permission of user A, user B could access the file, overwrite the file, or even delete the file. So clearly there is a need to regulate who can do what operations on the file. So this is where the operating system introduces the concept of file permissions. For every file, a set of permissions is defined. So for every user, it is clearly defined what are the set of operations they can do on a particular file. So let's say there is a file, then for every user it would be properly defined whether they can read the file or write the file, or for that matter, like do any other operation on the file or not. And once these file permissions are defined, any operation that is initiated by a user or a process that is launched by the user, that operation is first of all validated against the file permissions. If the requester of that operation does not have those file permissions, those required file permissions, then that operation is not allowed, right? So this is how the operating system enforces a protection mechanism over the data, that is files and directories that are present on the storage devices. So you see how when there are several applications in the computer system who are sharing a set of resources, in that case, the operating system has to provide certain protection mechanisms or safeguards so that it can be ensured that these resources are used in a proper way, so that no particular user application misuses any particular resource. So this was about the different protection mechanisms that the OS provides. Next, let us talk about security. So there are several features that the operating system provides in order to secure the computer system. So just now we talked about protection. What is the difference between protection and security? Often these two terms are confused to mean the same thing, but that is not the case. When we talk about protection, we are talking about safeguards against internal threats to the system. So basically we saw how when we have a set of shared resources and multiple applications which are using those resources, in that case the operating system implemented several protection mechanisms so that these resources are not misused. It's a check against internal threats, right? When it comes to security, in this case we are talking about threats which are external to the system. So if you talk about a computer, then there could be several threats that are external to the computer system. So in this case also, the operating system has to take certain measures or in order to secure the system. So let us see some examples to see what the operating system does in the context of security. The first example of a security feature is the user authentication. So whenever we boot the system, at that point we are presented with a login screen like this, where we have to enter the credentials, and here the operating system is trying to verify whether the user who is going to use the system now is actually the user that they claim to be, right? So after user authentication is done, then only the user is allowed to use the system. So this is how user authentication works, and authentication helps us to understand the difference between protection and security. So let's say there is a system where there are files, and those files have file permissions properly implemented. So there is a protection mechanism for the files in place. But now let's assume there is no user authentication. That is, whenever the user boots up the system, there is no login screen like this. So anyone who is using the system, there is no way to verify whether they are the owner of the system or not, right? So in this case, they can go ahead and do whatever operations they want to do with the file, irrespective of the file permissions, because there is no way to verify the user. It is assumed that whoever is using the system is the owner of the system. So here you see, although we have the protection mechanism in place, but it is not enough. We need a security measure on top of that protection mechanism, that is the user authentication, for the file permissions to work properly. So this is how protection is different from security, and this is one of the examples of security, that is user authentication. So the next security feature that the operating system provides is virus detection and removal. So there are certain pieces of software that are malicious in nature. Some examples are viruses, malwares, trojans. So basically these pieces of software have a harmful intent. For example, they could steal your data, they could make your system unusable, or they could just get access to your system. So basically these are pieces of software that are a potential threat for the computer system, and they are external to the computer. By default, the computer does not have these pieces of software, they come from external sources. So it's the responsibility of the operating system here to detect these malicious files, and once the detection has been done, then they have to be removed from the system to make the system secure. So these are some examples of the security features that the operating system provides. For example, user authentication, virus detection and removal, and so on. Another very important functionality that the operating system provides is exception handling. So what is an exception? So during normal computer operation, there could be certain events that happen which are unexpected in nature, and when those events occur, certain special or preventive action have to be taken by the operating system. So these unexpected events are called exceptions, and whenever they occur, the operating system has to properly deal with these situations. So let us look at some examples of exceptions and what the operating system does in their response. So let's take the first example of an exception. Let's take a process which is executing in the system, and let us suppose it tries to do something which is illegal, which is something forbidden for it to do. Let's assume that it tries to access the data that belongs to some other process, or let's say it tries to access device controller interface registers. So these are memory locations which are forbidden for a normal process. And whenever a process tries to access these locations, it's an illegal event or an unexpected event, and we can say an exception has occurred. Similarly, it could try to execute a privileged instruction. So there are certain instructions which are limited to the operating system. These are sensitive in nature and can change the behavior of the computer. Only the operating system is allowed to execute such privileged instructions. In this case also, if the user process tries to execute such instructions, we say that an exception has occurred. And in all of these cases, what the operating system does is that it terminates the offending program in order to deal with this exception. Let's take another example. Let's say a user is using a laptop which runs on a battery, and suddenly the operating system detects that the battery level is very low, and if the charger is not plugged, then suddenly the laptop will shut down. And if it shuts down abruptly, then unexpected things could occur. That is, system could go into an inconsistent state, data loss could occur. So the user has to quickly basically be alerted so that they can plug in the charger, right? So in this case, the operating system, when it detects that the battery level is low, it's an exception, and it has to deal with this exception by alerting the user. It could also turn on battery saver mode so that in any way it prevents the system from shutting down abruptly. Let's take one final example of an exception. Let's say you have a USB pen drive that you have plugged into your computer system, and you're trying to copy some file from that USB pen drive to your computer. And while that copying operation is going on, let's say by mistake you plugged out the USB stick. So what happens in this case? The device will now be not reachable, and the copy operation cannot proceed normally, right? So this is an unexpected event that has happened. It's an exception. So how should the operating system now deal with this? Naturally, the copy operation cannot proceed now. But what should it do with the partial file that is present on your computer? Should it keep that partial file, or should it remove that file? In any way, whatever the operating system decides to do, it has to handle this situation of device not found, this exception, in a graceful way. So these are some of the examples of unexpected events that could occur, and whenever such an exception happens, the operating system takes preventive action, deals them in a special way to ensure smooth computer operation. So the final feature that we are going to talk about that the operating system implements is the networking support. So when we say networking support, we mean that the operating system enables the computer applications or it supports the computer applications to send or receive data packets over the internet. So as you know, there are several computer applications which have this requirement of network communication when they are doing their processing. For example, there is the web browser, then we have file sharing applications, we have email clients, right? There are video conferencing apps. So all of these applications need to communicate over the network. And the thing is that communicating over the network is not a trivial thing. Any computer application which has to send or receive packets over the network has to do it by following a certain network protocol. So there are certain agreed upon protocols that each of the computer and the application that wants to communicate over the network has to follow. And it is the operating system that implements these protocols. So it runs these network protocols in the computer system. And whenever any computer application has to send or receive data packets, then it can leverage these network protocols that are provided by the operating system. So this is how the operating system supports the use case of communicating over the network for the user applications. So this slide summarizes all the different points that we studied in this video. So let us go over them once again. So the first point that we talked about, the first thing that the OS does is booting the system and shutting it down. This includes properly initializing the system and then closing it. The second point we talked about is the user interface. Here we saw how the operating system provides with a user interface which allows the users to launch other applications and interact with the computer system. The next point was about protection. Here we saw how the operating system implements certain safeguards so that the shared set of resources like the CPU, memory, the IO devices, the storage, how all of these resources are properly used by the different user applications. These checks are like prevent against misuse of these resources. So this was about protection. After protection, we understood security. What is the difference between protection and security? So in protection, it was about dealing with internal threats. In security, it was about dealing with external threats. So here we talked about examples like user authentication and virus detection and removal and so on. The next point was about exception handling. So an exception is an event that occurs in the system during normal computer operation, which is kind of unexpected in nature, and it deals immediate attention from the operating system. So whenever an exception occurs, in that case, the OS has to take some preventive action or do something special in order to deal with the exception so that the normal computer operation can proceed smoothly, right? We saw some examples like low battery, USB stick removed like unexpectedly, right? Or a process doing some illegal activity like executing privilege instructions, accessing memory locations that it is not allowed to. So this was the different examples of exceptions we saw and how the OS deals with them. The final example we talked about was networking support. So the operating system provides the networking applications with the support of network protocols. It runs these network protocols which are necessary for any computer application to communicate over the network. Basically, in order to send or receive data packets, they have to do it via these network protocols, and it is implemented by the operating system. So this was about all the different examples that we discussed. So these are the things that the operating system does apart from fulfilling its fundamental responsibility of managing the computer hardware. Another important point is that these examples are not exhaustive. There are many more examples. I have just included a few just to give you a basic idea. So guys, this was it for this video. In this video, we studied the different things that the operating system does to ensure that the computer is used in a proper and smooth way. And these are the things that it does apart from fulfilling its basic fundamental responsibility of managing the computer hardware. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.